Hey guys, all right, we are going to look at the second part of lesson 7.3 where we're solving linear systems using the method called elimination, or sometimes it's called just adding and subtracting. And so in our last lesson, we talked about how we could add or subtract the two equations to eliminate one of the variables and therefore be able to solve for the other one. So you could either eliminate x and solve for y first, or you could eliminate y and solve for x first, and then once you had one variable, plug it in. And we're going to continue practicing that. We're going to start today at example 3, and I'm going to add in something new where we might have to arrange the equations to line up. So in our last lesson, all of the equations were already lined up perfectly for something to eliminate. We had our x terms lined up, our y terms lined up, our constants lined up, and our equal signs lined up, and we either had to add or subtract those equations to get something to eliminate. Well, today what's going to be different is we're going to have to do some rearranging of one of the equations or both of the equations before we eliminate. So as you look at example 3, you can see that in these two equations, they don't line up, okay? We have here an x, here a y, x. Our equal signs aren't lined up. So we've got kind of a mess here. This isn't going to work to start eliminating because, again, they're not lined up. When you line things up, you need to line up the x terms, the y terms, the equal signs, that's important, and it gives you that hint over here, and the constants. It doesn't matter what order they go in. So you could go x terms, y terms, equal signs, constants. You could go y terms, constants, equal signs, x terms. It does not matter as long as they're lined up. So what I always suggest doing is to keep one equation as it is and move the other one to match whatever equation you're keeping. And the nice thing about that is then you're only having to move one of the equations as opposed to two of them, okay? So I'm going to go ahead and say that I'm going to leave equation 1 alone. I'm not going to do anything to it, which means I need to move around this second equation so that it goes in the order of the x term, the y term, the equal sign, and the constant. Okay, so right now I have 4y equals 3x plus 14. So I can see that I need to get the x term over to the left side. So I'm going to start by subtracting 3x from both sides. And I can either write it as 4y minus 3x, or you can keep change and immediately write it as negative 3x plus 4y equals 14. So you can switch the orders right there, or again, you could have written this as 4y minus 3x and then keep change and switch the order. It doesn't matter which way you do it. All right, and actually now I'm good because you can see I have it in the order x term, y term, equal sign, constant. All right, so now I'm going to take that first equation, the 8x minus 4y equals negative 4. I didn't do anything to that one. I just got the second equation to match the first one. So now I'm going to take my second equation that I moved around. So here, this negative 3x plus 4y equals 14. And hopefully you can see now we've got everything lined up. The x terms are lined up, the y terms, the equal signs, and the constants. So we're good to go. And now at this point, that's really the only thing that's new. This is exactly like the problems that we solved in the last lesson. So I'm looking to see what can I eliminate, and hopefully you see that the y's are going to eliminate. You have to decide if you're going to add or subtract them. Remember, if they have different signs, you want to add them to eliminate. If they have the same signs, you need to subtract them to eliminate. So these have different signs, so I'm going to add these two equations. Oops, I'm on the highlighter still. I'm going to add these two equations. So 8x plus negative 3x is 5x. The negative 4y plus 4y eliminates, which again, that's what I'm trying to do, is get something to eliminate. And negative 4 plus 14 is positive 10. So now it's pretty easy for me to divide by 5, and I get x equals 2, which again, I'm halfway there because I've got one of the variables. So then just like before, my next step here is I'm going to substitute 2 for x into either equation and solve for y. And so you can use either equation 1 or equation 2. And if you choose equation 2, you can either use it the way it shows up in the original problem or how you moved it around, because those should be the same. I always think it's better to go back to one of the original equations just to be safe, but either way should work. So I'm going to go ahead and take that I'm going to do the first equation. So I have 8x minus 4y equals negative 4, and I'm going to plug in 2 for x, so 8 times 2 minus 4y equals negative 4. 8 times 2 is 16, and so now my goal is to get that y by itself, so I need to subtract 16. I'm going to come over here so I have more room. I have negative 4y, don't lose that negative sign, keep change if you need to, equals negative 20. I divide each side by negative 4. And I get y equals positive 5. So now I have my solution, because remember my solution's an ordered pair, x comma y, and x is 2, y is 5. And so that would be my solution, the ordered pair 2 comma 5. Now I am going to do a check step here. I've told you I'm not requiring you to do a check step, but I think it's a good idea to, at the very least in your head, plug these in and make sure you get true statements. But on this one, we're going to work through the check step just so you're seeing more and more how you can do it to help you. And again, it's a great thing on homework, tests, quizzes to make sure you have the right answer. So the first equation was 8x minus 4y equals negative 4. So I'm going to plug in a 2 for the x and a 5 for the y, which gives me 16 minus 20. And again, I can keep change if I want. I do get negative 4, so negative 4 equals negative 4 is a true statement. Then I'm going to check it with the second equation, and I'm going to go back to the original before I moved it around when I check here. So this would be 4y equals 3x plus 14. So that's 4 times 5 equals 3 times 2 plus 14. So that's 20 equals 6 plus 14, which is 20 equals 20. Again, another true statement, so I know that I got the right answer. So again, very similar to the problems that we solved before. The only thing that is new and different here is that you have to do a little bit of rearranging before you eliminate. So we'll try a few more problems here. All right, let's practice a few more of these. So I'm at number 5 now. And again, as I told you before, I think it's easier to pick one of the equations to leave alone and move the other equation to match the one that you're not going to move or the one that you're leaving alone. You can move both of them, but it just makes more work than is necessary. So I'm gonna, in this one, again, leave the first equation. It doesn't matter which one you leave and which one you move, but I'm just gonna go ahead and leave the first one and then move that second one around. So I need to go x, y, equal sign, constant. So I can see again that I need to get that x moved over. So I'm going to subtract 3x so it cancels over there. And then I'm going to go ahead and put that x term first. So I have negative 3x plus 2y equals 6. And this now matches. So I can take my first equation, the 3x plus 4y equals negative 6. And the second equation, which is now negative 3x plus 2y equals positive 6. And I need to figure out if I need to add or subtract these. So I can see that the 3 x's are going to cancel. And so you could also see the constants. You're like, ooh, those 6's might cancel depending on what I do. But again, you're not really so worried about, I mean, it's okay if you eliminate the constant, but you're more concerned about how the fact that you need to eliminate one of the variables here. So the 3x is what I'm looking at. Remember, if they have the same signs, you need to subtract the equations, but if they have different signs, you should add the equation. So these are different signs, so I'm going to add 3x plus negative 3x eliminates. And that's good. That's what I was trying to have it do. 4y plus 2y is 6y. And then negative 6 plus 6 is 0. Don't be scared by 0. To get y by itself, I'm going to divide each side by 6, and I get y equals 0, which is great. I'm halfway there, and it's actually going to make it even easier when I plug in, because I can plug it into either equation. So I'll go ahead and plug it into the first one, 3x plus 4, and I'm going to plug in 0 for y, equals negative 6. So 4 times 0 is 0, so this is just 3x equals negative 6. Divide by 3, and I get x equals negative 2. So I think I have my solution now as negative 2 comma 0. And again, you're not required to check, but here's what I do. I just do like a real quick kind of like chicken scratch as I plug this in, and that's what I would encourage you to do. So I'm going to take 3 times negative 2 plus 4 times 0 and make sure that equals negative 6, and yep, I see 4 times 0 is 0, so this would just be negative 6 equals negative 6. Then I'm going to do it with the second equation, which would be 2 times 0, because I'm going to plug in that for y, equals 3 times negative 2 plus 6, so that's 0 equals negative 6 plus 6. And yep, that one works out too. 0 equals 0. So that just gives me more confidence that I know that I have the right answer, and it took me just a couple seconds to do, so that seems worth it. All right, let's move on to number 6. Again, I'm going to need to do some rearranging to get these into the same order. So again, you're picking one to leave alone and the other one to move to make it look like it. So I will go ahead and leave the first one just as it is, and I'm going to move that second one around so that it goes in the order x, y equals sign constant. That's what a lot of ours have looked like right now, x, y equals sign constant, which we'll see that type of equation frequently. It doesn't have to be in that order. All right, so I'm going to subtract the 4x, and I'm going to keep change so I can switch the order right away. So that's negative 4x plus 5y equals 6. So now I have these matched up because this goes x, y equals sign constant. So I'm going to take my equation. The first one is 2x plus 5y equals 12. My second one is negative 4x plus 5y equals 6. Again, it doesn't matter which order you add or subtract these in. Okay, so I can see that the 5y's are going to eliminate, but they do have the same sign. So the only way I can get them to eliminate is if I subtract these equations. If you added them, you end up with 10y. It wouldn't eliminate. All right, so I'm going to subtract, which means I need to subtract each piece. So this would be 2x minus negative 4x. So that comes out to be positive 6x there. And then the 5y's cancel because I have 5y minus 5y. And then 12 minus 6 is 6, so I divide by 6, and I get x equals 1, so I'm halfway there. And then I can plug that x equals 1 into either equation. I'll go ahead and just plug it into the first one. 2 times 1 plus 5y equals 12, so this would be 2 plus 5y equals 12. Subtract 2, 5y equals 10, divide by 5. And you get y equals 2. So this solution would be 1 comma 2. And again, once you get that first variable, you can plug it into either equation there, and you're going to end up with the same answer. All right, and again, I always like to do a quick check, so I'm going to do mine up at the top here. So in the first equation, I'd have 2 times 1 plus 5 times 2 equals 12, and I see that's 2 plus 10. So, yep, that one's good. The second one, I have 5 times y or 5y, so that's going to be 5 times 2 equals 4 times 1 plus 6, so that's 10 equals 4 plus 6. And again, I get 10 equals 10. So you don't have to do that check step, but it's a good way to give yourself the confirmation that you've gotten the same, or that you've gotten the correct answer. All right, good job on those. Why don't you take just a minute and try number 7? And then when you're done with number 7, so pause the video, try 7. When you're done, press play and make sure that you got the right answer. You only have to do number 7, not 8, just 7. All right, go ahead and double check your number 7 with mine. You should have ended up getting -15, -62, which definitely is bigger numbers than some of our past ones. Don't be scared if you get big numbers. Don't be scared if you end up getting some fractions. In fact, I'll give you a hint on your homework worksheet. There will be some coordinates that come out to be fractions. So again, if you get an answer that you feel a little like, ooh, like that seems like really kind of weird numbers, big numbers, fractions. If you're unsure, you can always do a check step. You see I did that in blue up above, and I did get true statements on both of those, and so that's a good way to confirm that you're on the right track. The nice thing about this one is you only had to, I kept that first equation, and then on the second equation, the x and the y were on the right side because they both were already on the left. So all I had to do was make an addition and switch the order there. So sometimes it's really easy to get them lined up, and sometimes it's going to take multiple steps. But before you can eliminate anything, the key is that you have to line up the x terms, the y terms, the equal signs, and the coefficients in any order you want, but each of those 4 things has to be lined up before you begin. All right, hopefully that helps. I hope you have an awesome rest of your day. See you soon.